understand some of the cases where we shall be making use of conservation of mechanical principle, or let's say how the energy is getting converted to work or work into energy in regard to the chapter gravitation. So we take the first case where we have two masses. This is, let's call it as M1 and let's call it as M2. They are separated by distance r. Their centers, they are separated by distance r, and this r is huge as compared to the dimension of these two, and both of these masses, they are at rest. We are neglecting the influence of the other masses around, and these two, they are isolated masses. They have been released from here at a distance r. So as a result of gravitational pull, they shall be moving towards each other. We are asked what is the velocity of this. Let's say if this is v1 and if this is velocity is v2, when the distance between their centers is capital R, we are asked what are the velocities v1 and v2. So what we do is, in these cases is we use conservation of mechanical energy principle. So over here we apply conservation of mechanical energy principle. That is, when we take the first case, P plus Ke for this configuration is equal to P plus Ke for this configuration. P plus Ke for this configuration means, what is potential energy? It is G minus G M1 M2 by R. This is the potential energy because of interaction between these two, because there is force of attraction between these two. So this is potential energy. Plus kinetic energy of this is 0, plus kinetic energy of this M2 is also equal to 0 because this is also stationary. Now because there is no external force which has been applied onto these masses, so it means the total mechanical energy of the system comprising of this and this mass, that will remain same, that will remain conserved, that will remain constant. So it means the initial total mechanical energy is equal to final mechanical energy in this configuration. What is the mechanical energy in this configuration? That is P. Now potential energy is minus G M1 M2. Now what is the distance between the two centers is R, plus kinetic energy of this. Suppose this is velocity is v1 and we say mass is m1, mass is m2, velocity is v2. So plus half m1 v1 square plus half m2 v2 square. So this is the final mechanical energy. Initial mechanical energy is equal to final mechanical energy because there are no dissipative forces. The total mechanical energy of the system is conserved. Now we see over here that is we have two unknowns, v1 and v2. These two values we don't know. One thing also to note is there is no external force onto this system. As a result, the momentum is conserved. Initially momentum is, which is a vector quantity, is 0. So it means m1 v1 plus m2 v2 when we write it in vector form. Or we can say, that is, if we write in the magnitude form, whatsoever the magnitude of momentum of this is this way, the same should be of this way in such a configuration. That is, right now if its momentum is m1 v1 over here and its momentum is m2 v2 over here, the direction they are opposite, and this should be equal to this, then only this vector plus this vector is equal to 0 because the initial momentum is equal to 0 only. So in this case, because there is no external force onto this system comprising of this and this, though there is a net force onto this, that is force of attraction onto this, though there is net force of attraction onto this, but onto this system as a whole, there is no external force on this system, because then this and this, they are the internal forces. As a result, we can say that is total momentum of this system is conserved. Be it over here, be it over here, the total momentum remains same. Initially, if it is equal to 0, then finally also it has to be equal to 0. It means m1 v1, it has to be equal to m2 v2. Magnitude of m1 v1, it has to be equal to magnitude of m2 v2. Direction, they are opposite. As a result, the net momentum is going to be equal to 0. Initially momentum is equal to 0. Finally also, whatsoever the momentum of this in this direction, the same is of this in the opposite direction. As a result, the momentum is conserved. m1 v1 is equal to m2 v2. So now we have these two equations. One is this in v1 and v2, one equation. This is second equation. We can solve these two equations to get the values of v1 and v2. So we can easily find the values of v1 and v2 in terms of g, m1, m2, small r and capital R.